Hello friends, welcome back to the bench. Our patient today is 2006 Subaru Forester. What's wrong with our Forester? This is a turbo version, which means this one has an IC608. But that's not why this board is on the bench. There are no problems with injectors, but there is a ignition signal missing on two rails. Now I know what you're thinking. If two rails are missing, this is probably this version where you have ignition on two wires. Ignition for 1 and 2 and 3 and 4, right? So either pin 18 or 19 is not generating pulse. But that is not the case. We have this model where ignition for each cylinder is separate, right? Now, this is still pin 18 and 19, but, hang on, yes, 18, 19, 20, 21. Which means, let's get you a bit closer here. So maybe we'll catch some good focus. B137, these pins 18, 19, 20, 21 over here. So we have two of them missing, which is pretty weird. This is I'm gonna tell you right now, this is pretty unusual case. So first thing we can do is find the chip responsible for ignition. Now, actually, a few words about the ignition, because IC608 does the injectors, but injectors are controlled with ground. So there's always 12 volts power supply rail always connected to the injector, and this chip just connects it to the ground. The ignition, on the other hand, is the opposite. So we expect a signal of 12 volts going from the ECM to the ignition coil. Now, ignition coil has 3 connectors: one for ground, one for power. That is the current that is actually being used to create the spark, and the signal from ECM just is, it ignites it. It's just a control signal. So we don't experience a lot of load on this chip, but with controlling the voltage, or the signal being a voltage applied, that means we need to create higher voltage than 12 volts to supply to the base. The base or gate, depending on what it is. Obviously, we can find what's inside that chip. That is always the case. ECMs don't use off-the-shelf components. Usually, the chips are available, like IC608. You can buy on eBay, AliExpress, and a few other places. This chip, the SE481, is not available. I mean, it's not on eBay, it's not on AliExpress, it's not available in any distributors that I use. This is Denso chip that D tells us, and supposedly it is available somewhere. That's what they say, but I don't see any, buy it now button over there or add to cart or anything like that. It's just, and the data sheet is also. There's like a field that says data sheet, but it doesn't do anything. So we don't know how this chip works, right? But first, let's confirm by connecting to our pins. All right, so they go 1, 2, 3, 4. All right, the missing signal is on 1 and 3 on the passenger side. So 1 and 3 are missing. So we should get different reading on 1 and 3, different than 3 and 4, 2 and 4, right? So let's go to number 1. That is one of the missing rails, missing signals. And let's check diode reading. It doesn't really matter which probe is connected where, because this is basically just a wire, and there's going to be a resistor on it. Was this number 1? Yes. We have 13 millivolts of drop, which means there's a 22 ohm resistor on the way, which is correct. And we can check it, confirm it with the resistance. 22 ohm. Well, it shows a little higher, but it's 22 ohms. All right, so that is on injector number 1. All right, so now on number 2, okay, so we have connection. Now we want to check between, and in this case, the polarity matters. So we want to put the red probe on the pin and the black one on the ground, right? And we got 1.3, 1.4 voltage drop on number 1. Now number 2. So number 2 is fine. Number 2 is working. Let's connect to number 2. Number 2 will be this one. And the same thing, 13 drop over here. And again, red probe over here. And back to the ground. 1.3, 1.4. Same reading, right? And the same reading I read on all the others. So number 3. And actually number 3, I don't remember which one it was. It was somewhere here. Was it this one? Nope. It was here somewhere. There. 3rd from the left. And 3rd from the left. And 1.3, 1.4. Right? And one last, number 4. We have loss on 1 and 3, so number 4 we know it should show exact same measurement. And it was also somewhere, oh, this one. Okay, first try. Nice. 2, 4, 6. Yeah, 6 from the left. 1.38. So we get, because one thing we would expect over here would be a short or different reading, right? But this is a meter that we're measuring. Now, it would be great if we could measure at the collector and at the base. But to measure at the collector and the base, we would need a data sheet, right? Without the data sheet, we don't know where to measure and we don't know what to look for. The second issue I mentioned was that the voltage for the base needs to be boosted. So probably this chip, because on laptops you usually have off-the-shelf components. So you have the gate driver for MOSFETs, and sometimes some kind of chip which is an array. And still you do get, but usually you get the MOSFET and the driver. as two chips, and usually few MOSFETs and one driver, right? At least two MOSFETs, sometimes four. In this case, we don't have that, and it's very unusual for that to be the case on the cars, because most of the chips are custom made, or at least custom applied, custom selected for the board, because, well, this is a mass-produced device, right? Yeah, and I know that the laptops are also mass-produced, but for some reason, majority of laptops use off-the-shelf components. Obviously, that goes to majority of them, except Apple, and they like to put the custom chips in there. But you know, other manufacturers will also put some custom chips on their boards as well. So we can deduce that both the driver and the MOSFETs or transistors are inside this chip. So since we can't measure at the gate or collector, that's the only measurement we can do. So we know there is no short, and the reading on all four is the same. We can't really go further from here. So my first idea, my first solution that I suggested to Willem was that most likely the cable is damaged. It's a wiring issue, because I don't see anything here. And on that car, there was an engine swap. The engine was, I guess the engine locked up, or you know, something else happened that the owner figured, well, we may as well just replace the whole engine. Which is in some cases it's actually a faster procedure than actually fixing the engine, ironically. During that procedure, it is highly likely that, you know, old wires, these wires been in there for nearly 2 decades or 18 years, right? This is 2006 model, so you know they're attached to the engine, right? They are covered, and you know they're not sitting on the engine block, but with, you know, they're close enough, so they're experiencing being heated up by the engine and then obviously being cooled down by the cold weather. So as long as you don't move the cables, it's fine. But if you move old cables, it's very likely they're going to start breaking. The insulation is already brittle, it's not flexible anymore. So once you bend the cable, you actually breaking the cable inside, even though that the insulation doesn't seem to be damaged. The cable is broken inside. It's very likely. That's what I suggested. But Willem actually performed measurements, and he measured at the ECM for signals for 2 and 4 are working, 1 and 3 are not generating signal, and he measured that with an LED. That eliminates the broken cable, missing connection. But I had a thought. If there is short on those cables, on those two cables, short to ground, then the measurement with an LED would show that the effect would be the same, right? It looks like the signal is not generated, because instead of lighting up the LED, it just goes to the ground. So that would also explain that would explain the measurement. That would explain the experiment, right? That would align with the theory. The other possibility is that this chip is faulty, even though the emitters or sources, depending whether it's a bipolar transistor or a MOSFET, they might read correctly as far as the voltage drop goes, but the chip itself is faulty. It's You know why I have a problem with this? It would be too coincidental. Because obviously, you replace the engine, you put the new engine in, so every single cable had to be disconnected from the engine. That goes to the ignition coils as well. The cables that go to ignition coils are wrapped around the engine, so not only you have to disconnect the ignition coil, but like disconnect the whole wire. Then replace the engine, put all the wires back together where they came from. It is very likely that something's gonna get damaged. And so now, after the replacement, two rails are not working. So what's more likely, the wiring or the ECM coincidentally stopped working, right? And it's not like you can perform or even start to perform this procedure when the battery is in the car. So that's probably the first thing you're gonna do, just remove the battery because it's in the way anyways. There's no additional battery in anywhere, right? If you disconnect the car battery, your clock needs to be reset, your radio stations need to be reprogrammed, like everything, there's no additional power source. So even if you started, messing with the cables and doing shorts, and suppose you shorted these, when you were working on them. So what? It's not powered. There might be some energy stored in the capacitors, but even if that be the case, it's not like this chip would be working or generating signals. What for? The ignition isn't even on. So I doubt that would cause the damage to the ECM. So you see how problematic it is for me to just kind of jump into the conclusion that the ECM is at fault. But I cannot determine that at the moment. And the only thing that I can do actually is just replace this chip. But if the replacement doesn't work or doesn't help, there's still a question of, are we receiving the signal from, say, this chip or this chip, right? Whichever one produces the signal for this chip, right? Because this is just the output stage. There shouldn't be too much brains on this chip. It just gets the signal from the heart. And this is when this is when you need to ignite cylinder number 2, and even the length of the pulse doesn't really matter, because in the injection the width of the pulse is crucial, because that decides how much fuel is going to be supplied. So it's much more complex operation. This one is a lot simpler. The pulse can be a little longer, a little shorter. It can be the voltage can be a little lower, a little higher. Doesn't matter. All we want is a spark. It's there's not much to the spark, right? So if we replace this chip and the problem doesn't go away, we still don't know whether the control signal from the CPU is not coming to the chip. And no way to know that without the data sheet. At least data sheet for this chip. I'm not saying I need a schematic for which would be awesome, by the way. But I'm not saying I need a schematic or a board view for this. Data sheet for this chip is enough. And I'll figure out, because I know this is 1, 2, 3, and 4, right? So I know these are in meters, so I just see which pin is the gate for these, and they just follow to the chip. But even if all I can confirm is that there is a continuity between those two. And again, I gave it thorough visual inspection, and there's no signs of any physical damage. There's no signs of liquid damage, and there's no signs of oxidation. There's nothing. The ECM is in perfect condition. I mean, even I was considering maybe to resolder this one, but no, that only causes causes a fault on the injection rail, because that's where the length of the pulse is important, and all that stuff. It's a much more responsible process. It's a much more crucial process. The ignition is not. It's just one pulse and that's it. We don't really care. So I don't think resoldering would solve any issues over here, even though this is the third generation. There are no problems with injectors, right? So this is one of those boards that never experienced the IC608 problem, right? So yeah, this is what I can do. I can order, so I can't find this chip new, but I can go to eBay. I can order this ECM. It's not exactly the same. This is 741. The one we have here is 752. Not exactly the same, but I expect the chip is going to be there. We could probably ask the seller to just open it up and take a picture of the board to confirm the chip is there. But that's roughly $50, right? On top of that, I have to replace the chip, right? So I gotta take this one off, clean the board, take the chip off the other board, clean the chip, transplant the chip over here, and resolder it. This is pretty close to, unlike IC608, that seems to be rather isolated here. So it's a lot easier to work on this one. This one is accompanied by a lot of logic around. So if I start blowing here, this cap is going to start floating. This transistor, is it? Yeah, this transistor is going to start floating. I don't know what this is. All this stuff is pretty close. There's not going to be a lot of room to put a lot of Kapton tape. So that's something I got to charge $150 for, to replace this chip, which takes us to a total of roughly $200. For $200, you could buy a board, exact same one as this one, for roughly $50, hopefully, and have it reprogrammed for roughly $150. You shouldn't pay more than $150 for reprogramming. So the option number 2, reprogramming, at least you're certain that it's going to help. You're going to throw in $200 and you know it's going to help. With replacement of this chip, you throw in $200 and it might help, it might not. So I'll give you this choice. If you need, I'll see if I can put you in touch with the guy that might be able to reprogram this one. I know he does the other boards, and he's done some Subaru boards, but I'm not confident whether this is the particular one he can reprogram. I don't know what it entails. I don't have tools for that. And I also have another guy, but he's in Canada, so probably you don't want to send it internationally. But I have another guy that probably would also be able to do that. But that's what I would suggest. Just get the replacement board. But first thing I would do is check for shorts on those two wires. Because if those two wires are shorted to ground, that explains our observation, and that confirms that there's nothing wrong with the ECM. I mean, if they're shorted to ground and this chip was pushing pulses to the ground, I don't think it would get damaged. There's that 22 ohm resistor. That's probably a limit of the chip. So I assume even if you connect it completely to ground, it's not gonna. The chip will still be fine. I wouldn't expect it to be faulty after that. But yeah, that is pretty much it. That's all I can do for you, Willem. So yeah, I will actually email you right now, or maybe first I'll publish this video and then I will email you, and we'll go from there. Unfortunately, this one is not an easy fix. When we were talking about it, I was, I was pretty upfront about it. That I need to take a look at it, and we'll see. I can't guarantee anything because it depends on what the measurements will say. And I was hoping that there's going to be a short. There's going to be something that I can confirm with measurements. But there's nothing that I can confirm with measurements. And my gut feeling tells me that there's nothing wrong with the ECM. It's a matter of wiring. But that's just my gut feeling, because it makes sense. It would have to be so coincidental that you replace the engine and then suddenly some weird issue on the ECM pops up. Right? Very coincidental. I'm not saying it's impossible, obviously, but very, very unlikely. I would say very unlikely. Well, that's where we stop. Willem, thank you very much for your business. I'll talk to you in a minute. And thank you guys very much for watching. I hope you found this useful in any way. I'll see you guys in the next one.